Educrafts.com, and the Educrafts Learn is offering you the courses based on the Pythons, and slowly we will move to the machine learning where we'll be learning more about the NumPy, Matplotlib, Pandas, Seaborn, TensorFlow, etc. But for all these we need to have a programming language called Python, because however, you can also do machine learning with other programming languages, but our focus is mainly with the Python, because the Python is most popular programming language used with machine learning. So here I just try to elaborate my new second further statements in that, like the last video you saw conditional statements. Here we are seeing the second part of the conditional statements called the if elif. Elif it is called. Like the last condition you saw that only conditions was like if condition, if condition, else this. So the nature goes like this: if condition is true, then here this part of the this block of the code will be executed, and if it is false, then this block of the code will be executed. And if you want few more conditions, like suppose if you have some more analysis, then the only option was there, then you can add some more condition inside this. If this condition, else, like this is called the idea of nesting of the if statements. But Python provides you another alternative where you can do the condition checking 3 or 4 or too many times, as much as you want. There the syntax goes like if condition, then execute this line of the code, elif, elif condition, then execute this line, these lines of the codes, second line, yeah, this block of the code, again elif condition 3, then you can say this block of code, and else you can write the remaining. You can keep improving the elif conditions, like the condition 1, condition 2, condition 3, and out of all these conditions only one conditions will be true. So either this block of the code will be executed, or this block of the code will be executed, or this, otherwise this. So out of these 4 segments only one condition will be true, and only one particular block will be executed. For these kind of situations, now we have a very famous equations, like how to solve, I make it as statements, how to solve a quadratic equation x square plus bx plus c equal to 0. So I'm trying to solve that one. For that we will be taking a b c, the coefficient of x square, coefficient of x in the constant term from the user, and it goes like this. Yes, so enter the, I change this one as enter the coefficient of x square, then enter coefficient of x, and then enter constant term. So after, when all these three number coefficients are entered, then the program does calculate discriminant of the equation, since d square is b square minus 4ac. So this is b into b minus 4 into a into c. So this one gives you the idea of the discriminant. Now we know the condition that if discriminant is like here. If discriminant is, if d is greater than 0, then we will have two roots, and these are called the unique roots, two real valued roots. And this one is x1 equal to minus b, then plus, we need to import sqrt function, so import math, then we will use sqrt math dot sqrt d, and then this whole thing will be divided by 2a, all, so 2 into a. So this one gives you the idea of the first real root. I simply copy and paste it, so I'll get my second root x2, and here I'll have minus b minus, then I'll check if discriminant is equal to 0. If discriminant is equal to 0, then this sqrt part doesn't make any sense, and you have only need, you need to write control v, so this part does not make any sense, so you can write minus b over 2a, and x2 will be x1, because this is condition of the equal roots. So if these two things happen, then third condition is that if discriminant is less than 0, elif, then we know that a number can be either equal to 0 or can be greater than 0 and or can be less than 0. So if I have already taken the two condition, so else will bound to have the only third option, which is d less than 0, and we know that in that condition we have to write print roots do not exist. Here we'll write print roots are x1 and x2. I copy the same thing here, and now I think we are ready. Let's see how it behaves. So first it says enter the coefficient of x square. I enter, for example, suppose if I take 1, and then I'm just taking the example as x square minus 4x plus 4, so this will be minus 4, and the last will be also 4. So this is the case of the equal roots where the roots will be 2 and 2. Now it says the roots are 2 and 2. Now I rerun again to check whether other conditions are true. So first I'll write 2, then 7, and then we'll write the last one as big, because we want the discriminant to fail. This condition appears to be a case where the root doesn't exist. Let's see what happened here. First I stop the previous calculation, run it again. So I enter 7, then 9, then 900. So the roots do not exist because in this condition discriminant, that is 9 square minus 4 into 900 will be negative number, and the square root of the negative number is not possible. Now the next condition is try to have whether the equation have the equal roots. So I enter is, suppose I take the two variables and the roots are 3 and 4, so it will become x square minus 7x plus 12. So I just take it the coefficient of x square as 1, and then it is minus 7, and then it is 12. So the roots should be 3 and 4. Here it is 4.0 and 3.0. So this is the basic nature of the if elif statements, we can say. So you can, in this situation, you can calculate, you can have the more condition checks, and this is the best way of doing it. Thank you very much. Subscribe to our channel and stay tuned, because we are just try to do more and more of the mathematical and programming syntax things. Next video will discuss more about the loops. Thank you very much. Have a nice time. Stay tuned.